Hi everyone, so here we're going to talk about the concept of isotopes. This time we're going to just deal with the notation as well and the definition. So you're going to need your notes as well as your reference tables. We're talking about the definition of isotopes as well as their notation or how they're written, different isotopes of hydrogen, and then go through some review questions. So down here we have a neon lit sign. So if we can take a look at a little sample of this sign, we have this area right over here, this circle that they show us, the little diagram. So the the red dots indicate neon 21, and neon 21 has 11 neutrons. The yellow ones are neon 22, which have 12 neutrons, and then the blue ones are neon 20, which have 10 neutrons. So if you look at the sample, not all of these atoms of neon are the same. They are atoms though, because they do have the same number of protons and electrons, but they're not all going to be the same number of neutrons. So if we look here, we have isotopes are two or more atoms of the same element with different number of neutrons, but then they'll have the same number of protons and electrons. So here again with this sample, not all of these neons are the same, but they are still neon, just with a different number of neutrons. So we look at isotopic notation. We've seen this notation before, whereas carbon-12, the 12 represents the mass number. So whenever you see the element symbol, so here we have carbon, and 12 at the top, this is part of the isotopic notation. So you can take a look at any of these and see that the 12 at the top is the mass number, and the C represents the carbon. The only thing missing here is actually the number of protons. The number of protons come down here at the bottom. So we know that carbon, any sample of carbon will always have 6 protons. So if we take a look, the element X represents the element, or the symbol, excuse me, represents the element X, and my pen is not going to write really well, sorry guys. And then at the top we have the mass number, and then bottom we have the number of protons. If we take a look at carbon-13, we can write it out as carbon, the mass number of 13 at the top left, and 6 protons down at the bottom left. And then carbon-14 is 14 neutrons, and again 6 protons. Sometimes you'll see it that they don't actually have the number of protons, but that doesn't matter because you can actually know what the number of protons are based upon what the element is and use your periodic table. So the top number represents the number of protons plus neutrons, so use the symbol NEU for neutrons. The bottom number represents the number of protons. So if you subtract the top minus the bottom, you should get the number of neutrons. So if we take a look, 12 minus 6, that means that we have 6 neutrons in this sample, 7 in this, and 8 neutrons in this sample. Hydrogen is pretty unique. It has also many isotopes just like carbon does, except their isotopes have different names to them. So hydrogen 1 is just one for the mass number and 1 for the number of protons. So if you subtract, this actually has 0 neutrons. Deuterium has, if you take a look, 2 as the mass number, 1 as the number of protons, so that's actually 1 neutron. And the third one actually has 2 neutrons. So make sure you memorize these symbols. You might be asked about these later on. So you will need to know that you have hydrogen 1, the name for hydrogen 2, the name for hydrogen 3, and what their notations would be. So let's take a look at some questions. First one, which pair of nuclei represent isotopes of the same element? So here the P stands for protons, the N stands for neutrons. We want to know if we want to have isotopes, and it has to be the same element. So the two of them in there need to have the same number of protons in order to be the same number of, the same element. But they have to have a different number of neutrons. Let's take a look. First, we'll look to make sure that they're the same element. So this one has 10 protons, this has 11 protons. These won't be the same number of protons, so they actually are different elements. For B, we have 5 protons, 7 protons. This is not correct. For C, we have 3 protons here and 3 protons there. So they're going to be the same element. Now we need to make sure that they have a different number of neutrons. So this has 3 neutrons and that has 4 neutrons. So this is our answer. Sometimes what they'll do is they'll tell you 3 protons and 3 neutrons, and another one will be 3 protons and 3 neutrons. These cannot be isotopes of one another because they don't have a different number of neutrons, so make sure you don't get tricked up by that. So the second question, which nuclei is an isotope of 10 protons, 11 neutrons? And again, this is just showing you the inside of the nucleus, it's not showing any of the electrons. So again, we want the same number of protons, but a different number of neutrons. So we have 10 protons here. This one has 11, that has 11, that has 9, so D must be our correct answer. Let's double check the number of neutrons. Yep, they're two different sets of neutrons, so they should be isotopes of one another. For this one, which isotopic notation represents an atom of carbon-14? So if we remember, the top number represents the mass number, so that's what this one will be, and then the bottom number represents the number of protons. So we want to make sure that the top number will be 14 and the bottom number will be the number of protons. And just to double check, we can take a look here. Carbon is located right here, and it has 6 protons, which is its atomic number. So we want the mass number to be on top, which is not any of these except for this one. Sometimes you might see that it has like 14, 6C and then 14, 7N as some of the answers. So, like say for example, this was choice E. Even though the 14 is on the top, that's fine, but they're not going to be representing carbon because we have a completely different element and a different number of protons. And here, what's the total number of neutrons in an atom of 5726 Fe? So the top number represents the number of protons and neutrons, the bottom number represents the number of protons. So to figure out the number of neutrons, we just have to subtract them. So we should have 31 neutrons in this sample. So isotopes are two or more atoms with the same number of protons and electrons, but a different number of neutrons, and make sure you know how to use those notations. Have a great day, guys.